My name is Rivas, and I'm going to briefly touch upon a design pattern. It's actually chain of responsibility, not chain of command. I think I gave the wrong info, but it's called as chain of responsibility. So before I go through this, is there anybody who wants clarification on what a design pattern is? Okay. So let me give you a gist of what a design pattern is. Design pattern is a repeatable solution to a commonly occurring problem in a computer design, in a software design. When you say repeatable, so there are three keywords here, repeatable, which means that when that problem occurs, if you apply the solution, it should always pass. Commonly occurring, it has to be commonly occurring problem. If it's just a one-off problem, we don't really consider it as you don't really include it in a design pattern. So it is a commonly occurring problem, it has to be repeatable, and it is a software design. So it is not code per se, it's a very high level thing. It just gives you a high level idea of how you are going to go solve that problem. So that's the design pattern. And chain of responsibility is a solution to a commonly occurring problem. So what I'm going to be touching upon is what that problem is and what is that high level solution. I'll show you a bit of a code, but I am not going to execute anything. So how many of you have heard chain of responsibility? Okay. If more hands had gone up, I could have stopped, but okay. Okay, so before I actually continue with this, I'll briefly tell you guys a story, just to make this. So in an organization that I worked in previously, there was an architect. And the architect came upon this cool idea about how he could save his company a few hundreds of thousands of dollars, maybe more. And the idea was simple. He was an architect, he was high level up, he had design discussions with almost every product engineering team that was there. He basically saw the architecture of all these products. And what he found is that there were these commonly occurring problems, that almost all product engineering teams were facing. And mostly that were related with cloud deployment and how do you identify devices uniquely across different platforms, things like that. Sending data to big data, telemetry, things like that. So his idea, and the products would implement the solution just to get by, they would implement it, but that problem was not really pertaining to the product functionality. It was something that they would implement as a side byproduct. And those solutions were rarely efficient. So his idea was simple. Let's build a team which focuses on that commonly occurring problems. This team will build security into it. This team will build performance into it. This team will take care of, if there is a server that you have to set up, he will make sure that that server is always loaded perfectly. If it crashes, then there is a follower. Things like that. Licenses are efficiently utilized. Licenses are very expensive. So, product engineering teams can now share a license, right, with this process. So I was working in that team for a very long time. So before I continue, so there is a commonly occurring problem that happens when you give a solution like this. So what is our component? Our product is basically a component that other product engineering teams kind of integrate into their installer. They bundle it along with the installer. So now you have a user system, you install product 1, that user system is going to have product 1, it's going to have version 1 of our product. Now what happens when another product 2 comes in, which has version 2 bundled with it, right? So you're going to have product 1 over there, product 2 on that system, you're going to have version 2 of our system, of our component, right? It's going to overwrite version 1. So we have to be very careful that product 1 functionality is not broken because there is an upgrade. So one of the requirement was that it's a strict requirement. We had to support all the releases that we had done previously. The backward compatibility was a very strict thing. So in that context, so now imagine that I have a product 1, I have a set of test suites. So we had test suites for every product that integrated. It was a minimal set of test cases just to ensure that we are not breaking anything. So I have a product 1 test suite. And within that product one, I have a function which is called as login, right? So there you have. So I've kind of given you pseudocode over there. What does it do is basically you have a test suite and you have a test case called login. And we basically execute, we basically made sure that, it's working fine. It's working fine against the QA environment, it's all good to go. But then it starts breaking, because what we didn't realize was that there is another staging environment. And staging environments, we had assumed it would be the same, but it wasn't the same, because client teams rarely care about, how the environments are. They just care about what gets returned to them. They just want the data. But we care, right? Because we are there in between the client and the server, right? So we care about it. And basically, you see that failure. So we did a backup. We wrote something like this, right? And what's wrong with this? The problem with this is, tomorrow, if that fails, and this actually failed, because the product one has different SKUs, and different SKUs implement the login functionality differently. It now no longer used a browser, right? It implemented it differently, and so the staging environment also started failing. So now you have a problem. You got to have one more function. You got to have one more implementation. So this kind of starts breaking down. There are a lot of problems with this. You basically have to keep on writing if else conditions. So this kind of breaks down, and this is where you can use chain of responsibility, right? And what is chain of responsibility? Chain of responsibility. That's my I actually wanted to change it. It's actually a chain. It's not a file. Okay. So it's actually a chain. And how does a chain work? You've got one link. That link is QA server. You attach another link to it, the staging server. You attach another link to it, product SKU, right? And you can attach more links, as many links as you want. And the chain of responsibility, you basically now start seeing, you start writing your test case this way. Test suite is equal to product one test. Now that's your test suite. You initialize it with, say, product SKU, and then you call login. What happens when you do this? Basically, when you call login, you have that login, he goes to QA server, he says, are you responsible for it? So basically, I will now pass my object, the test suite object, whatever test suite there is, I'll pass it to QA server, and I'll ask him, can you check whether you're responsible for this? And he says no. Goes to staging, and basically QA server will hand the patent to staging server. Staging server checks. He says, are you responsible for this? Staging server kind of says, puts his hands up, he says, no, I'm not responsible for this. Staging server sends the object to product SKU, and product SKU looks at it and he says, yes, I'm responsible, because you kind of initialized it with something. This is really not the best solution. I just want to give you a very simplistic overview on where you can use this. So this is not really the best place where you can use it. I'll kind of touch upon it if we have time. So yeah, so that is the basic modus operandi of how chain of responsibility works. And chain of responsibility, because you are kind of handing down responsibilities down the chain, right? Now, ladies screaming, I'm responsible. Right now, so Aravind kind of touched upon what generators are. And I'll give you a gist. He explained it better than what I could have. Generators are basically iterators, right? You iterate through a list of values, just like how you would iterate through a list, right? In Python, how you would iterate through a list. A generator function returns you an iterator through which you can iterate. Now, these QA server underscore login, staging server underscore login, product SKU underscore login, they're all iterator. They're all generator functions, which means they give you back a function which you can iterate through. So basically what that means is there is a yield statement somewhere inside that. Okay, so let's look into that later. Here's what I was talking about. When you call login, it's got this generator function here, right? This actually returns you a generator function. You can call a next or generator function, and what does next do? It returns you the first element, right? Now, when you return next, he actually goes. So here, if you look at it, QA server underscore login is the generator function, and you have passed in a staging server underscore login as an argument. So that becomes the successor. When you call next, he basically implements this, and if there is a yield statement somewhere over here, he basically goes and stops over there, right? Then you send him something. And here, when you're sending self, you're actually sending him that object. So you remember what I said, right? It's like a chain, and you basically pass the test suite object to QA server first. QA server has to go check if he's responsible for it. If he's responsible for it, he will execute. Otherwise, he'll pass it on. So this is how I send the object. I pass that object to that QA server underscore login. And this QA server underscore next is basically getting the first element, or basically the first element. And that is my chain. Okay. Now let me show you what's happening inside QA server underscore login. Okay. So basically, when you said QA server, when you said chain dot next, he comes up here and stops. He stops at that yield. And when I send an object, test suite object, that gets initialized to test suite. Now here he actually does that checking. He says, okay, is the test type? I haven't actually put it. You would have passed it in the constructor. But here, when you say, you check, okay, test suite or test type, is it QA server? Then I'll execute it. Else, the successor, the generator function that was passed as the argument, he will call next upon it. And he has a similar function. He has a similar kind of logic. He'll basically come and stop at that yield. When you send test suite, whatever object you got here, he passes it on to staging server underscore. Does anybody have any queries? I'm sure people have queries. But yeah, if anyone wants to clarify on what, so this is the chain of responsibility. This is how it works. You have a chain, you have different links, and it just passes on that object figure, and the guy actually decides, like, each of those functions actually tries to figure out if he's responsible for it, else he'll pass it on to the next person. So is there anyone who has a query? Anybody who didn't understand it? Okay, now the reason why I said that this is not the best way you could do it, there is another way you can do it. There is another design pattern known as factory pattern, and he does it much more simply, in a simplified way. What does a factory pattern do? When you call product one test QA server, he basically goes there, he calls a factory, and the factory gives him a function. The factory will basically tell you which function you should implement. Which function, when you call login, which login should I call is basically decided by this factory. He gives you that function, right? And it's pretty simple. I just implemented it in this way, in this factory. If you had passed QA server, he basically returns QA server underscore login. That's the function. And your functions are way simpler than what it was in chain of responsibility, right? So this is probably not the best way that you can, the chain of responsibility is probably not the best way you can use in this particular scenario. But in my scenario, I basically, let me go back. Yeah. So in my scenario, it was actually, I used it because I didn't know if this guy was, I didn't have an environment at the point of time. I didn't know beforehand, which function should I return back. He actually went into the QA environment. The QA environment did some stuff like, look into login host file, and then he realizes, okay, this is actually pointing to another environment which is not mine. So let me pass the data now, right? So there was a set of steps that he did, and I didn't want to put that set of steps inside a factory function because it's not the responsibility of factory function to do all that stuff. The factory function will just give you a function. He shouldn't even go to the host files and all that. It's a responsibility of this guy to say that he's responsible for it. So that is why I use chain of responsibility. So there are some, there are scenarios where you can use one solution, and there are other scenarios where you can use the other, another solution. So that's just the gist of what chain of responsibility is. Any queries?
So all design patterns generally use generators and functional programming?
No, not necessarily. I mean, if you look at the factory function, I didn't use any generator. There's no generator inside. So I mean, you could have implemented chain of responsibility without a design pattern. I mean, without a generator, right? But it's just
An example.
it's just nice to look at, right? Python's offering you that, so it's kind of just nice to look at. But again, you can do it without it. All you have to, all that function has to have is a successor, right? That's all he needs. So basically, you just have to pass that.
So you mean like any built-in design pattern is there in Python?
Any built-in design pattern.
Any example? I don't know. I'm just asking. Is there any example design pattern is there in Python built-in library?
I don't think there is a built-in keyword as such for design
There are a lot
pattern.
of design patterns. One is generator pattern. So if you read more
That
about
is
it-
a functional programming.
No, design pattern that is program.
That's why I'm asking. I don't know. Is there any specific word like design pattern we use in the Python library?
No. So design patterns are you should
It's
use it
only
more
just
as
a concept.
yeah, it is a concept. It's a high level. So that is what there is no code behind it. You basically look at that problem and then you basically use a design pattern to solve that problem.
So you mean like we implement design patterns, we design design patterns using Python features.
Right. Now even C++ does the same thing, right? And C++ also has, even C++ doesn't have any, it doesn't use generators in the same way that Python does. But he also can implement these design patterns. So design patterns are basically just an indication, it's like a guideline which tells you how can you make your code more neater, more scalable, less error prone. So these are just guidelines which are given, while you're designing.
Because I remember I've seen a book, Java Design Patterns. I'm not sure whether it is inbuilt to Java feature or not. I don't know. I'm just asking.
So even Java design patterns would be something of the same sort. It would explain to you what those design patterns are and how you would implement it. Right. Anybody knows what's wrong with this if function? Why is this so wrong? I mean, what's wrong with this code?
Restrictive. It's very restrictive. It's only for that particular.
There are a lot of things that can go wrong in this. I mean, in the sense, yeah, you're right. Like, first of all, you'll have to go in, you'll have to actually go in and make some changes over there. Another problem that I found is QA server underscore login. Sometimes it is QA server underscore login, but it fails. And then he will actually go in and check staging server underscore login. So basically, he will go through the entire list of if else things. I mean, you could implement it in a way, but yeah, if this you actually have this problem that it might go through the entire list if it's an actual failure, right? So it's much easier to debug as well. Like if I have some error messages which are pertaining to a particular QA underscore environment, then I can actually say, okay, QA environment was responsible for it and it failed inside that. This doesn't give you that.
So the number of if conditions here and in the other design pattern, is it the same or different?
There are no if conditions with that design pattern. If you look at that, I just call login.
Okay. You pass the required environment as an argument.
Yeah. You needn't have done it. I didn't do it. Basically, it went to the QA server and he figured out if he was responsible for it. But yeah, so just to illustrate, yeah, I actually passed this as an argument to the test object. Just read out. Okay. So if there are no more questions, I'm done.